So the next result is about this property, Laplace transform of t to the power n. The Laplace transform of t to the power n. This is one result. This is equal to what? That we have to write. So what is this equal to? The Laplace transform of t to the power n, this is equal to n factorial divided by s raised to power n plus 1, or you can write the Laplace transform of t to the power n, that is the gamma of n plus 1 divided by s raised to power n plus 1. So now what is this? What is this n factorial and what is this gamma of n plus 1? What are these quantities? So let us first discuss this factorial term. So this factorial is calculated for positive numbers only, positive numbers and 0. So it is defined like this. So we have 0 factorial, this is defined to be 1, and then if you have n factorial, this is equal to n multiplied by n minus 1 multiplied by n minus 2. We'll keep on doing this until we reach the last digits 3 into 2 into 1. So what is this 4 factorial? So it would be equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So it would be equal to 4 multiplied by 6, that is 24. So similarly you can calculate the factorial for any kind of number. So if you have the Laplace transform of t to the power n here, so it would be n factorial divided by s raised to power n plus 1. So this is about factorial. But what is this term gamma of n plus 1? So for that, let us see what is this gamma of n plus 1. So what is this quantity? Gamma of n plus 1, gamma is an integral transform, special kind of integral transform. It is defined like this. Gamma of n plus 1, that is nothing but integration from 0 to infinity of this quantity e to the power minus x, x raised to power n dx. So this n is representing this power of x here. So this is a special kind of, transform, integral transform, right? But we are because we are dealing with calculations of this gamma n plus 1, so what we'll do, we'll study some of its properties that would be useful in calculation of this gamma. So the first property is that gamma of n plus 1, that is equal to n gamma n. So suppose you wanted to calculate this gamma of 10. So what would be this? You could write this to be 9 plus 1. So you could write this to be 9 gamma n, gamma 9. So again you could write this gamma 9 to be 8 plus 1. So this would be 9 into 8 into gamma of 8. And then again you can write this 8 to be this 9 into 8 into 7 into gamma 7 and so on. So finally you would, what would you obtain? You would obtain 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 into gamma 1, right? So this is the quantity that we obtain, and the value of, and here you could write the value of gamma 1 is nothing but 1. This you could check when you substitute n is equal to 0 here. So when you substitute n is equal to 0, you have x raised to power 0, that is 1. So you will only perform the integration of e to the power minus x from 0 to infinity. That comes out to be 1. So gamma of 1 is 1. So eventually this becomes 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So this is nothing but 9 factorial. So you saw what is this gamma of 10, this is nothing but 9 factorial. So from here we got this relationship, that another property, that the factorial, this gamma of n plus 1 is nothing but n factorial. So this is another property that we obtained from here. First property was this gamma of n plus 1, that is equal to n gamma n. Second property was gamma of 1 is equal to 1 third property here is this one, gamma of n plus 1, that is equal to n factorial. Moreover, for the fractions term, we have the gamma of 1 by 2, that is equal to square root pi. So this is always true. And this gamma is required whenever you have this fraction terms, because this factorial is defined or calculated only for positive, or you could say non-negative, because 0 is also included, non-negative integers, not integers but whole numbers, right? So whole numbers. So that means you could calculate it for 0, 1, 2, 3, 4 and so on. You cannot calculate for half, you cannot calculate it for 3 by 4 and quantities like this. So for that we use this gamma of some particular quantity. So now, because we know what is the value of this 1 by 2, so now if I ask you calculate the value of this gamma of 7 by 2, what would be this? You could write this 7 by 2 as 5 by 2 plus 1, gamma of this 5 by 2 plus 1, and now using this relation gamma of n plus 1, that is nothing but n gamma n, so you would have 5 by 2 gamma of 5 by 2. So now again you could write this 5 by 2 as the sum of 3 by 2 plus 1, so this is nothing but 5 by 2 as such, this is nothing but 3 by 2 into the gamma of 3 by 2. Then again you can write this 3 by 2 as the sum of 1 by 2 plus 1, so this becomes 5 by 2 into 3 by 2 into 1 by 2 into gamma of 1 by 2. And what is gamma of 1 by 2? It is square root pi, so its value becomes 5 by 2 into 3 by 2 into 1 by 2 into square root pi. So this is the value of this gamma of 7 by 2. So this is how you calculate gamma and factorial for different quantities, right? So the formula that is of importance here is to calculate the Laplace transform of t to the power n, that is defined either to be n factorial divided by s raised to power n plus 1, or it is defined to be, for whenever your n is fraction, so in that case it is defined to be gamma of n plus 1 divided by s raised to power n plus 1. Here in this case we can write this to be whenever n is positive integer, and here in this case we can define this to be n to be the fraction. So suppose we can look at one example. The example is, or the question is, find the Laplace transform of t to the power 5. Now because 5 is a positive integer, so its formula would be 5 factorial divided by s raised to power 5 plus 1. So we have the final answer as 5 factorial divided by s raised to power 6. Now it is up to you, you wanted to solve this factorial or not. So when you solve this factorial, you would have 5 into 4 into 3 into 2 into 1 divided by s raised to power 6. So this becomes 20 into 6, so that is 120 divided by s raised to power 6. So that is the Laplace transform of 5 by 2. So now let us see another question. What would be the Laplace transform of t to the power 5 by 2? Now here, because this is fraction, so we would use the formula of this one, the Laplace transform of n plus 1. N is 5 by 2, so we have 5 by 2 plus 1 divided by s raised to power n plus 1. So 5 by 2 plus 1. The formula was the Laplace transform of t to the power n, that was equal to n plus 1 gamma divided by s raised to power n plus 1. So we have used this formula here. So this becomes 5 by 2 into the gamma of 5 by 2, right? And this becomes s raised to power 7 by 2. So you can further simplify this, 5 by 2 into 3 by 2 into 1 by 2 into the gamma of 1 by 2, right, divided by s raised to power 7 by 2. So this finally becomes 5 into 3, 5 by 2 into 3 by 2 into 1 by 2 into square root pi divided by s raised to power 7 by 2. So you can simplify this. You would have 15 square root of pi divided by 8 into s raised to power 7 by 2. So that is the final answer, right? So next let us see one more question. The question says find the Laplace transform of, find or evaluate this Laplace transform of the function f of t, where this function f of t that is given to be this quantity 1 whenever t lies between 0 and 1, and it is equal to t whenever t is greater than or equal to 1. So for that we will use the definition to solve the Laplace transform. So by the definition of Laplace transform, it is equivalent to integration from 0 to infinity of the function f of t e to the power minus st and dt. So now because the limits are from 0 to 1 and then from t varying from 1 to infinity, so we could break this limit. So we would have 0 to 1, then the value of f of t e to the power minus st dt, and then the limits varies from 1 to infinity f of t e to the power minus st dt. So this is what that we got. What is the value of this f of t when the limits are from 0 to 1? Its value is equal to 1. So we have integration from 0 to 1 into e to the power minus st dt, and then we would have from 1 to infinity. What is the value in this interval? The value here is t. So we will use this value here, t into f of t, sorry, the value of f of t was t. So t into e to the power minus st dt. So now we can solve this one. What is the integration of e to the power minus st with respect to t? It is e to the power minus st. So the integration here would be e to the power minus st divided by minus s, limits varying from 0 to 1, and then its integration would be, we have to apply by parts. So it would be first function as such. So t as such, the integration of e to the power minus st divided by minus s, limits varying from 1 to infinity, and then minus integration 1 to infinity, derivative of first function, integration of second function dt. So this is what we got. So now if you substitute the limits here, minus 1 by s being constant would come out. So when you substitute the value of t as equal to 1, you would have e to the power minus s, and when you substitute the value of t as 0, so you would have 0 here. And in the second term, when you substitute infinity, so you would have limit b going to infinity, b e to the power minus sb divided by minus s, and when you substitute the limit 1, you would have 1 into e to the power minus s divided by minus s. So this is what you get. And when you perform this integration from the second term, you would have minus e to the power minus st divided by s square, and the limits here varies from 1 to infinity. So in the first term here becomes minus 1 by s e to the power minus s, and the second term becomes minus 1. So we would have 1 by s here. And then when we substitute the limits here, because of this term, because we have e to the power minus infinity here, so we would have e to the power minus infinity. That means we would have 1 upon e to the power infinity. So that means it becomes 1 by infinity. So that means this term would be 0. So this term won't be there. So we have 0 here, and then plus e to the power minus s divided by s, and then here again we have to substitute this limit infinity. So limit b going to infinity, e to the power minus sb divided by s square minus e to the power minus s divided by s square. So this is what we got. So you can again simplify this, minus 1 by s e to the power minus s plus 1 by s, then plus e to the power minus s divided by s, and here also because this term b goes to infinity, this term would go to 0. So we will be left with plus e to the power minus s divided by s square. So this is the final answer, and this is the Laplace transform of this function f of t, defined to be like this. So next